So, good afternoon and welcome CCW and Nathan. I'm Leon here. So, today I'll be sharing with you on how to use Inventor to do CAM turning. So, if you guys have purchased PDMC collection, Product Design and Manufacturing collection from Autodesk, you have the Inventor that it should include the CAM Inventor CAM extension to allow you to do CAM simulations such as turning and milling and 3-axis milling or 5-axis milling, so on and so forth. But today I'll be mainly focusing on how to use Inventor CAM to do turning. Okay. So before that, we need to understand how to use each and every different tool that's available in CAM, Inventor CAM. So over here, there are a list here where there's turning profile, turning groove, turning face, turning single groove, chamfer, part, thread, and stock transfer. I'll slowly explain each and different features and their use cases in which scenario, which one would we be using, okay? Okay, so first one, turning profile. So turning profile is usually used to get the outline of your model. So let's say you often for turning, you start with a cylindrical part and then you use turning profile to just get the outline of it, but it is very rough without any proper finishing with it. So turning profile actually has two types. One is turning profile roughing and another is finishing. So roughing is just getting the outline and finishing is smoothing it out, getting a better surface on our model. So next one is turning groove. So groove is for cutting the indentation of your parts. Example shown here. So over here, there are parts where it is difficult for example, the turning profile just now to reach. So often turning groove is used in this case so that it's able to reach places which are deeper so that it makes a cut inside an indentation. So next, turning face. So often our stock, our turning part, we have extra material spaces to allow any kind of error. So we have to cut it out using turning face to smoothen out. Basically, let's say by right, my parts at the front there should be 10 mm, let's say, but I basically have to use turning face feature to cut that part out. It's quite straightforward for this. So moving on to the next slide. So turning single groove, it's similar to turning groove, but just that turning single groove is often only used for one groove, as the name suggests. And also turning groove, it only goes in once and retracts right away. Unlike turning groove, where turning groove can just goes into the indentation and drag as well. If you want it to retract and go back inside, it's possible as well with turning groove. So most of the time, we will be using turning groove instead of turning single groove. Okay, so turning chamfer is basically cutting up sharp corners of our model. So let's say some of our models, our parts, they are designed to have a chamfer. So using sometimes roughing, you can get one of the chamfers done, but it might not be very accurate. So what we can do and use is using turning chamfer. And also at times, our cutting tool is moving from left to right. So what if our chamfer is from the right, on the right side? So you might have to use chamfer tools instead of turning profile to get the chamfer done. So turning part, this is just basically cutting off your tools off from the stocks once you have completed your roughing, finishing, grooving, and chamfering. So next one is turning thread. So this basically creates a thread around your parts so that it's allowed for screws or anything with thread to screw inside. It can be on the outer surface or even in the inner surface of your part. Example, a hole with threadings inside. It's possible with turning thread features as well. So the last one is turning stock transfer. This is slightly more steps than the few previous features, whereby if you have parts where there's, let's say, a part which is symmetrical, both sides has slanting. So you can only start off with one part and do a general roughing, finishing. After you finish one part first, then you need to use this turning stock transfer feature, which is using secondary spindle chuck. Basically, another chuck comes in and hold onto the other side, and then secondary spindle return. Basically, you want to release the primary spindle and then let the secondary spindles turn and continue and move on to the last half of your stock. So after understanding all of these features, let's go right into one of our example at Inventor. Okay, so over here, I have a part ready, and this is an example. If you want to follow up with this tutorial, or if you want to try and practice it at home using the same model, you can actually get it from here. Let's say you have a new file. Let's say, let me close this. You can go onto CAM. Once you have installed the Inventor CAM extension, you will have this CAM tab on your Inventor, top bar of Inventor. So you can click onto it and then go to Browse Examples. So in Browse Examples over here, look for tutorial 6. This will be the example I'll be using for today. Double click onto it, and then you'll be able to see the parts. So right now, turning parts, if you have noticed, most of the features are available on this side, slightly to the right side of the middle. So there's profile roughing, finishing, groove, and this is face, part, and this is turning thread. So this is the stock transfer, grabbing, and return. This is the chunk, this is the return. And the other part which is important is the job site over here. Every time whenever you start CAM simulation, always start with this part and then go onto your specific feature. Example turning, I'll be using this part over here. If it's exists 2D milling, then I'll be using these features tools available. So let's get right into it. I'll start with clicking onto setup. So once I click on setup, on the left side, the panel here, a window will pop up. There are multiple selections. The first one, setup, the machine here, you can select if you know which is the machine that you'll be using to do the simulation. And this is actually only for visualizing. But for this case, there is no general turning machine available in Autodesk sample. So I will not be using it. And the setup here, this is the most important operation type, which one we'll be using. As I've mentioned just now, there's milling, turning, cutting, and additive here. So we'll be mainly using turning, but at the same time, if you are interested, you can explore in milling and how to use it for cutting, and additive is for the 3D printing, how all the filaments, the supporting 3D print will be like. So right here, I just click onto it, go into turning. Once you have selected it, so the spindle for now, we'll be using primary spindle as our model here. It's only need to be cut on one side. Here, if you should be in select Z-axis, plane or plane and X point. But the most important thing to select here is actually just the Z-axis. And let's say your Z-axis is not selected by default. So what you can do is just click onto it and go to the rotary axis, which often any part of the cylinder will work. any circle, since this determines the rotary axis. And then we'll notice on our screen here, there is save Z, which is the safe retract area. And if I rotate to the back here, this is the chuck. So the chuck is basically the parts that's holding it. At cases, your chuck will be at the front. So to move it to the back, what you can do is just click on flip Z axis. But since my case here, it's by default at the back, so I can just untick that. X axis from point is not needed to be selected. So let's scroll down. So save Z over here is basically the retraction part. 5 mm is enough, but if you want it to be safer, you can select 10. So if your tools is very large, you can possibly go even higher offset value to protect your tools from your parts, from your stock. And the model is also by default selected for you. If it's not, let me show an example. Just select the model that you have created, the part that you have created before. And then the chuck references will be using the back as default. We just leave it as it is. Moving on onto stock. So the stock setup here, the mode, we can select different type of stock available. But since for turning, we'll be using fixed size cylinder. If you use relative size cylinder, it's just getting a general outline of your part. But often we use fixed size cylinder, but there are also other type of options here, like from solid. It's basically just using our solid. Maybe you can use this to further do some type of chamfer or profile roughing example. But this fixed size box is not recommended for turning. So we just go back to fixed size cylinder. So over here, we can change up the diameter of our stock, maybe 110, and the length maybe a little bit longer, 120. So all this depending on your factory preset, which type of materials, which type of stock you have, you can do the according the settings lah. Okay, after that's done, the last part, the post process, the program name, you can name it however you want, but for this case here, maybe I can just name it CAM turning. And you can leave a comment. So this WCS offset is basically the origin offset, but for this case, we'll not be touching it. Click on OK. So your setup is basically done. Once the setup is done, you can move on to doing your profiling, your grooving, and faces. So right here, for this part, I'll start off with doing the most, from the most left-hand side all the way to the end. So here, I'll be using turning face. And turning face here, once you selected it, similarly on the left side, the window will pop up, and then you can select the tool available. So the tool here, if you notice, there's already 3 tools included: general turning, grooving, and threading. But if you open up a new part, you might not have all these tools ready over here. Instead, you have to dig around and look for it yourself. And where do you find them? You can just go under here, all tools, by type over here, click onto it. And if we are doing turning, just look for turning, general turning. Click onto it. So these are the tools available for turning. And then I'll just go back and select the tools. So for cutting faces, we'll be just using a general turning, a cutting tool. Once you selected this, you can click on select. But let's just say this, for example, you have different cutting tools. Your general turning tools has a corner radius of 5 mm, much bigger. Let's just take that as an example. You can click on edit over here, and in insert here, you can change up all the thickness, the corner radius of your cutting tool. But at this case, I will not be changing anything. So I'll cancel and just select the default tool. So once selected, you will be able to see the tools. It's inside our simulation, our parts, our drawing space. The coolant, you can choose the different type of coolant, but I'll just go with flood. And I'll use a spindle speed instead of using a constant surface speed. I'll just use a spindle speed to set it. And since it's the face, we want it to have better finishing. So we'll use a rather slower speed of 500 RPM. So today I'll be mainly using spindle speed of 500 RPM and 1000 RPM. This all depends on your machine capability, but I'm just using this two for an example. The slowest speed will be used for finishing and the higher speed will be used for roughing. So I'll go with 500 and moving on to the next part, the geometry. This part, we nothing much for face to do. But if we go into grooving or profile roughing, I'll talk about it later. Similar at this clearance, ray track, outer radius, but this basically shows the general direction of where our stock is at, where our tools will be placed at, the clearance place, and this inner radius, which I'll be using for face, is because sometimes our tools is a little blunt. So if we just make it to have perfectly zero offset, you might leave a pointy little part at your part at the face there. So what I can do is select, change this offset distance to cut below into 1 to 2 mm higher. So if you notice on this side here, if I make it back to 0, this is by default 0. It cut until the center of your part and stop right away. So what I can do is just select 2 to make sure it cuts completely through. And then passes, I'll also use multiple passes just in case my tools is too small and the stock is too big and it cannot cut in one pass. So I need multiple passes to cut through it. Once that is done, the next thing, linking here, there's nothing much for us to do. All of the settings should be at default. Full retraction, preserve the rapid movement for your spindle and feed rate, and click on OK. Then you can actually do this. Right click on your setup over here, your tools, and click on simulate. So this here is the tool path, and this is the simulation. So I believe by default, the stock here, it's unticked. So if it's unticked, then you will not be able to get the general idea of how your stock looks like and how the cutting will look. So to do that, just click on stock and then show transparent. If it's not transparent, you will not be able to see your model. Click on show transparent and close. Sorry, my bad. Right click, simulate, show transparent, and then you can just click on the play button to cut. And you can adjust the speed at the bottom side over here. At scenarios, let's say, this is the playing bar, the timeline. There are cases where there is a red bar, like this is a black bar, right? But let's say if there's a red bar, it means that there's a clash or there's an error. You can click on this stop on collision to do a troubleshooting. So once that's done, I can close. So after face, I'll use profile roughing, click onto it. Tools, we'll be using the same tool. Select outside profile profiling. The speed this time I'll change it into 1000. And the model, the geometry, I'll just stay as it is for profile roughing. I'll change it for grooving, and I'll explain why later. Clearance, also similar, nothing to be changed over here. And then click on OK. So similarly, you can see the tool path over here. And next up, I'll be doing a profile finishing to make our surface smoother. Same tool. And then the speed here, instead of 1000, I'll change it to 500. And all this model clearances, the radii, the cycle, it's always from front to back and allow radial grooving. And we're able to let it have making sharp corners, turning, allow it to have dragging. If not, we'll be always retracting our tools and pushing it back. And lastly, just click on OK. So profile roughing and finishing is done. And the next thing will be doing a profile groove. So if you notice, this is profile grooving and there is a single groove, but I'll just use groove to demonstrate. So grooving is different from profile roughing and facing. So faces. So we can just go to tool this time and change into turning grooving. So the tool is basically a stick with a cutting tool and select. And then over here, I also just leave it as 500 RPM. And this time, my model, my geometry, I'll give it a restriction. Since I'm only going to be grooving this one indentation, I can just click on stop front here and choose selection. So I'll be selecting this part over here. And for the model back, similarly, I'll select this part over here so that it has these two range, and my tool will only be doing grooving within this range. Next thing, the clearance, the retract, outer radius, they are all relatively safe in my opinion. So I'll just leave it as it is. Similar for passers. And I'll select for grooving. I will not select up and down. I'll select only, if you can see over here, I'll be selecting only up so that my tools will retract back and not be dragging in this. To avoid cutting onto extra stocks, click on OK. So let's try and simulate what we have over here. So I can click on simulate and I notice, oh, at the back here, there is holder collides with stock. Basically this whole part over here, let me just drag fast forward, show it to you. There's no issue until this part over here, where my stock clashes with my grooving tool. So what I can do is right click, go back into edit, and from here, the up and down direction, I have to allow, instead of only up, it should be only down. And then finishing passes, number of steps. You just leave it as it is and click on OK. Let's try and simulate again, see if the issue is still there. It is still there. But okay, generally you have to make the tool be able to retract backwards so that it does not collide. Or second scenario is that currently the tool is too big. That is the reason why it's colliding. But in my opinion, this currently why it's colliding is because it is using dragging motion, and I should be disabling the dragging motion. Going back into edit and look for no dragging. Repeat finishing passes, use packing, pass overlap. Let's take it as 0. Let it allow rapid retract. And then from my memory, it should be only up and passes overlap should be 0. these have to be troubleshoot one by one until you get it. So I can possibly select partial step down, let it step down one by one. Use packing motion as well, so it will track. And let's try. So if it's still colliding, yes, it's still colliding. Maybe I'll leave it until next time. Maybe you can leave it in a YouTube comment once I'm done with this. I'll just close this, and then the last part will be chamfering this two little angle here. Actually, for this part here, our profile roughing is already done it for us. But to demonstrate it, I'll just select turning chamfer. Similarly, the tool, I'll be using this CNMT tool. Select. I'll be using flooding normal, but this time over geometry over here, I'll have to select the chamfer. So I'll click from one side here. Let me just change it onto the top view. One side here, and then it will auto generate for me. And chamfer 45-degree angle according to our parts. Or here, you can adjust the chamfer angle 40, let's say. So I'll just leave it as 45 right now. Chamfer, okay, chamfer 1, 2, 1, 2. So that it aligns with it. But often you can only just choose one part over here, and then you decide what at what angle you will be cutting. So it is quite straightforward for chamfer, and the rest at the back here, there's not much to do unless you want to adjust the chamfering width, the extensions, and the angle especially. Click on OK, and let me just simulate this thing here only. If I were to only simulate one, if I were to only simulate one, the whole stock will still be there. So hence, you'll see it's still there instead of doing a profile roughing. So once all of this is done, what we can do here is right-click, simulate, and make sure there is no collision or anything. And then once everything is done, you can just close it and right-click on your setup and select post-process. So this is the main part after you have done all the simulation. And for this case here, you can select the different type of machine you'll be using. For this case, is turning. And the different type of vendors, the brand of your machine, I'll be using Fanuc. And then right here, I'll select Fanuc turning. But this depends on which type of machine you'll be using to generate the G code for your turning machine. And you can, like just now, you can name the program turning and program command turning sample. And once this is done, you can also select which folder you want to save it at and click on post. So program name setting must be a number. So let's just change it into a number instead. 1001. Let's go back to default. Post. And then save it. So give it some time for it to load. Field save position style to ZX. Let me see what's the issue over here. Oops. Post process. Command unit and Fanuc. Seems fine. Oh. 1001. Post. Save. Similar results. Okay, but let's just take this whole thing for example. after you have done through all of these settings, and over here, you can actually change the value of your home position for your tools, your spindle. And if your spindle has a little offset, then you can also specify it over here. And then there are cases where there's a sequencing, like number one, line number one, number two in your G code, right? You can also disable it through this setting part over here, where use sequence numbers, you can just turn it to off, no, and then you can change the sequence number increment, and then just click on post. But for this case, I'm not too sure what exactly happened on my side, because I think the PC is currently newly installed Inventor CAM and some of the setting is not done properly. So, but generally, once you have done all of these settings, you should be able to post without any issue. And then that should be all for today's free online lesson. And I would like to introduce you to our company's website, where acadsystems.com, where over here we are Autodesk Gold partners for reselling and training. So at our website here, you can always get up to date with our latest promotion for our softwares. Currently, we have a flash promo. And then if you scroll down even more, we have a event that's upcoming event, free online courses and lessons. And on the 17th, we actually have an event at Seremban site for Autodesk Design and Manufacturing on sustainable design and innovation. And all this upcoming FOL, you can click onto it and then reserve your seat here by clicking on going. Once that's done, you can also scroll down all the way to the bottom of our website and click on YouTube here. Make sure you subscribe and leave a bell icon, because right now I'm using our current account, so I am not able to show you the button. So that's all for today's FOL. Is there any question? So if there's no any questions, I will end the meeting right here. Thank you for attending.